standing by. I'm Selina, your moderator for this session. Welcome to our webinar on managing agile development best practices. First of all, I'd like to thank each and every one of you for taking time off your busy schedules to attend this webinar, and I hope it would be a learning session for you as well. At the outset itself, I'd like to encourage all participants to type in any question and answers that you may have in the chat window on your on the right hand corner of your screen. So I'd just like to get started with our agenda for today. So we would be discussing about we just give a brief overview about what exactly is Agile project management, how do you get started with Scrum, and why does Agile work. Then we'll be moving on to what's the need for good engineering practices and what are good engineering practices. So with that, I'd like to introduce our speakers for today. Before we get started, I'd just like to mention that the way we'll be structuring this presentation, we have two speakers for today, and the presentation would take close to about 50 minutes. Each speaker would take about 25 minutes each, and we would have 10 minutes at the end for a question and answer session. So you can type in any questions that you have during the session at any point of time, and we would take that up for discussion at the end of the session. To introduce our speakers for today, we have Siddharth Govindaraj from Silver Stripe Software. Siddharth is the founder of Silver Stripe Software. He has about more than 5 years of experience in Agile development practices and methodologies. He's been involved in developing tools for Agile project management, and he's been associated with the Agile Software Community of India in a very active manner. We have the next speaker is Hari Sudashan Rangarajan from Aspire Systems. Hari is a solution consultant at Aspire Systems, and he's extensively used Agile with different projects in different team sizes, and besides being an advocate of Agile, he specializes in high performance database design, and he has interest in taking up product integration challenges and helping Aspire's development teams implement best practices in best engineering practices. So with that, I'd like to also give you a brief intro about Aspire Systems. So Aspire is a thought leader in outsourced product development. We've made more than 1,000 plus product releases to date. We have several ISVs, several reputed ISVs as our customers, primarily in North America and Europe. We have about 500 people team and offices in main office in Chennai and Chennai, India, and global offices in the US. So with that, I'd like to hand it over to Siddharth. Over to you, Siddharth.
Thank you, Selina, and hello to all our listeners, wherever you may be. Now, before I get started, I just want you to take a moment to think about what are the challenges facing your software development today. In getting your projects out to the market, what are the single most biggest challenges that you face? Now that you've thought about that, I want to put forward what I think have been the big changes in the environment over the last 15 years. The first thing is that time to market and quality have become more important than ever before. And the second is that requirement stability is a thing of the past. There used to be a time a few years ago when we could talk about making releases of our product once every few years. Then that became once a year, then once a quarter. Today companies like Google, Amazon, Yahoo make multiple releases a week. So getting their features out to the market at such a rapid rate presents unique challenges. The second big point is that requirement stability is gone. At one point of time, you could count on doing the requirements in the beginning and delivering your software a year later and being sure that the requirements are not going to change in between. But with the way the market's changing and with the new challenges facing software development companies, they're finding that their customers want to change requirements often. And this is providing a challenge to all these companies. As a program manager in this environment, you're faced with these challenges and you're thinking, how can I improve my software development and my software delivery in this kind of environment? The problem has been that traditional processes which we have relied on for so long are no longer working. You see, traditional processes have come out of large defense projects and government projects over the years. That's where our traditional processes have really evolved from. And these projects have certain unique characteristics. Typically large budget projects which go on for multiple years, and they're very critical in the sense that many lives could be at stake. And while software development did start this way and our processes evolved from this background, today over the last few years, more and more software is getting written for consumer and enterprise applications as compared to defense projects. Yet our processes have not changed. We're still using the same old processes that were evolved for these big projects and trying to apply them in the consumer and enterprise space and finding it challenging. That's where Agile project management comes into the picture. A lot of people have faced these challenges and they've decided that traditional processes just don't cut it in the new environment. And they've come and evolved their own processes, and over a period of refinement, it's become what we can today call as Agile project management. So Agile project management are basically a set of processes which are created for the environment of changing requirements, quick time to market, the new environment that we operate in. So with that, I'll get down to my first point as to what is Agile project management. I've been talking all this while saying that Agile project management adapts to the new environment, but what exactly is it? What you see on the screen over here is what is known as the Agile Manifesto. And the Agile Manifesto lays down a set of guidelines for processes. Any process that adheres to this manifesto is called an Agile process. And the manifesto has 4 main points. You can see them on the slide here. Individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Now, all the items on the right-hand side are valuable, but what we say in Agile process is that the items on the left side are even more valuable. And if you look at it, you'll recognize that the items on the right are what we concentrate on in traditional processes. And Agile says, let's leave that focus and focus some more on the items on the left. So individuals and interactions is one very important focus area in Agile. And just to take an example, let's take the third point of customer collaboration over contract negotiation. In traditional processes, it's very important to negotiate the scope of your project upfront, sign off on a contract, and then deliver that scope at the end. And anytime the requirements change, you always have a complicated process to try and minimize the number of changes in your project. But then imagine what happens at the end. You started off with a project, midway the customer required some changes. And for some reason you said like, okay, that's not in the original scope, so we can't do those changes. And at the end of the day, you deliver a product which may adhere perfectly to the original scope, but because it no longer meets the requirements of the customer, he's unhappy. So what Agile says is that this isn't really the way to go about it. What we need to do is collaborate with the customer and accept the changes, so that at the end of the day, customer has a product which actually satisfies his requirements. Now, there are a number of processes which actually adhere to the manifesto. Agile is not a single process, but it's a generic name given to any of these processes which adhere to the manifesto. I've given here a list of some processes: Scrum, Extreme Programming, Feature-Driven Development, Lean, DSDM, and Crystal are some of the most popular ones. Out of this list, Scrum is by far the single most popular Agile process. So in the rest of the presentation, I'm just going to talk about Scrum. I encourage all of you to find out something about the other processes as well. But for now, we are just going to talk about Scrum. With that, we get to the second point, which is getting started with Scrum. Let's say you want to implement Scrum, then how do you actually get started and go about it? Scrum consists of three main roles. You have the product owner, the Scrum master, and the team. The job of the product owner is to act like a proxy for the customer. So basically all business decisions, all decisions relating to which features are important, which features have to be done now, what can be postponed for later, all these kind of decisions are taken by the product owner. Anytime there's a question about the product, should we do it one way or another, the product owner takes the call. So the product owner has to understand the customer's perspective well. Typically, the product owner is also a domain expert. The job of the Scrum Master is to make sure that everything goes smoothly. You can think of a Scrum Master as a coach in any sports team. The Scrum Master doesn't actually do the work, but his job is to make sure that everything is working smoothly, everyone is aligned in the right direction. The Scrum Master's job is also to remove obstacles. For example, if the development team face a hurdle, it's the Scrum Master's job to remove the hurdle so that the development team doesn't have to waste their time on things like this. They can get on with doing their job of delivering the software. And finally, you have the team. The team encompasses everybody who actually delivers the software. That may be your developers, your testers, UI specialists, database administrators. All these people are collectively put under the team. So we have some practices for team composition, which are good practices to follow in Scrum. The first is that the team is generally cross-functional. In other words, we don't have a separate development team, a separate testing team, a separate database team. Instead, everybody involved in the project sits together in one team. The second is that it's co-located. So everyone again sits together in a single room so that the developers and the testers can talk directly. There's no need to go through managers or documentation in order to communicate between the developer and the tester. A little later on, we'll also look at distributed Agile, where the team doesn't sit together or someone doesn't sit, maybe the customer or the product owner doesn't sit with the team, and what do you do about it? But generally speaking, teams try to be co-located. And the third point is that the team is self-organizing. In other words, they don't need micromanagement. They don't need someone else to tell them this is what you're going to work on and this is what someone else is going to work on. The team commits to a certain amount of work and then they figure it out by themselves on what's the best way to approach it. Ultimately, since the team is the one doing the work, they have the best experience in knowing how it should be done. So this is how Scrum works at a very high level. The product owner takes a list of features, prioritizes them, and this prioritized list of features is what is known as the product backlog. Once the prioritized product backlog is ready, the product owner, the team, and the Scrum Master sit together to form what is known as the sprint backlog. Now, how Scrum works is that it's iterative. So you have a number of iterations, also known as sprints. So to take an example, let's say your project extends over 6 months, then you'll probably divide it into 6 sprints of 30 days each. So the team sits with the product owner, decides what are the features that we can commit into doing in these 30 days, which comprises the sprint. Then for the next 30 days, they go ahead and implement those features that they committed to. And at the end of the sprint, you have a working increment of software. Now the key point here is working increment. All the features done during the sprint, you have to do the requirements, you have to do the coding, the testing, the integration completely, and it has to be working software. So you don't want a case where the team takes a bunch of features and does only the analysis for them. That's not what we want. At the end of every iteration, you want to build one subset of the system from end to end. So that's a quick high-level overview of Scrum. Once you have implemented one sprint, then you again repeat the process. You choose another set of features, implement it in the second sprint, and so on and so forth until the whole project is complete. Now, what do you do if the team is not sitting in the same place? Increasingly, we are seeing global teams, we are seeing distributed agile in action. And the key practices for distributed agile is to have small iterations. So traditionally you might be having 30-day sprints. In distributed agile you might decide to go in with 2-week sprints. Secondly, you need to have project management tools in place because people from different locations don't know what is happening in the other location. So you need a project management tool that they can all look at and be synchronized upon. And third, you need communication tools. Because people can't talk face to face, you need a number of instant messaging tools, voice call tools, desktop sharing tools. All these help when you do distributed agile. And later on in the presentation, I'll give you a link which has a lot more information on distributed agile. So you're doing Scrum. Now why does agile work? What does agile have going for it that traditional processes don't? Basically, agile is designed to tackle 3 main risks. These are risks which traditional processes suffer from, and agile manages to mitigate these risks. So let's just have a look at them. The first is building the wrong product. This is a huge risk in traditional development. You do the requirements up front, and the customer doesn't see any software till the end of your project. That could be a year, it could be 2 years. So in case there's been any misunderstanding midway, in case there's been any problems, it's not until you actually release the software back to the customer that he actually sees that this isn't what he really wanted. So that's a huge risk. But with Agile, you're delivering a working increment of software every 30 days. Therefore, the customer can actually see what you've done every 30 days. So in the first 30 days, if you've done something wrong, the customer can give feedback immediately and put you back on course. So that's a huge plus point that Agile has going for it. The other thing is that Agile, because you keep releasing every 30 days, you can get your features into the hands of the customer much quicker than traditional processes can. The second risk is a lack of visibility. When the customer is giving you a project to do, the customer never really knows how far you are in the project because it's not until the end that software is tested. You could have done requirements analysis and coding and then found out right at the end when you're doing the testing that you've got a lot of bugs, which basically negates a lot of work which you had done previously. And you suddenly find out at that point that you're not as far down the track as you initially thought you were. And this is a huge problem. What Agile does is because you do testing for every sprint, if you finish successfully one sprint, you can be pretty sure that amount of work is completed. You can put it down in your schedule that this work is done, and then you know that maybe 1/6 of your project is done. You're not going to get nasty surprises at the end of your project regarding the work that you did right at the beginning of the project. And the third big problem is a lack of quality. Again, we've been talking about how traditional processes defer testing right to the end. And this is a big problem because by that time a lot of things are set in stone. Whereas with Agile, we do quality right from day one. Every sprint we are talking about working features being developed. So that's a big plus which Agile has going for it. And in the second half of the presentation, you'll be hearing about engineering practices like test-driven development and continuous integration, which are Agile practices to add more focus on testing, on quality right from the start. So these are the 3 main risks that Agile addresses inherently in the process. So the question facing all of us today is, can companies adapt to the new market? The market has changed, the environment has changed, and now it's up to companies to adapt their processes to suit this new environment. The way we should look at it is these new changes are not problems. Getting features quicker to market, dealing with changing requirements are not problems, they are huge opportunities. And companies that can get themselves to work well and deliver software successfully in this environment will have a huge leg up over their competitors who are still working on traditional processes. And agile management enables companies to take advantage of these opportunities. The opportunity is there, it's just up to the companies to go ahead and start taking advantage of it. So this is the link I mentioned earlier in the presentation. It's www.toolsforagile.com/resource/aspire, and at this URL we have some more resources. This presentation, there's been quite a bit of breadth covered but not much depth. So there's a lot more information at this URL if you want to dive in deeper into the subject of Scrum, of distributed Agile. You can do so at that link, and that link is, we've set it up specially for all of you, the listeners, to this webcast. And with that, I'd like to hand it over to Hari, who's going to talk about the engineering practices you need to develop Agile projects. So over to you, Hari.
Hari, just before you start, I'd just like to take a minute here to ask our audience if they have any questions, even at this point of time. We can take a quick few minutes here to address any questions, if there are any questions, just to make it a little more interactive. So if you have any questions, you can type them in your chat window on the right-hand corner of your screen, and Siddharth would take it up right away. If you're not getting any questions, we'll just go ahead with the presentation. So over to you, Hari.
Hi. So one of you just asked a question saying that you got a 404 for the URL. The URL should end with a slash. So it's /resource/aspire, and there's a slash at the end. Okay, we got another question about distributed Agile. What kind of communication tools we use? So the idea in distributed Agile is that when teams are not co-located, you need to get more communication. So at the URL, we have a list of tools. I'll just take up a few of them. One is instant messaging, so that developers at different locations can chat with each other. Similarly, you can go in for Skype so that they can talk over voice. Then you have web conferencing software like Live Meetings, so that you can have design discussions. You can set up a webcam at both locations and stream the audio and video through web conferencing software. You also have desktop sharing tools so that two developers can share a single desktop and work together on a particular piece of code. And then you have things like wikis, which allow you to put lightweight documentation online. You don't need complicated formal documentation, but then if you use wikis, teams in different locations can easily update an online copy of your documentation. So these are some of the tools that we can use for increasing the communication. Okay, we got another question on forecasting schedules and cost to complete without documentation and with frequent changes. So there are two aspects to this. One is forecasting the schedule, and this is actually a topic by itself, but very briefly, what happens is, because what you do product end to end. You can judge how many features you actually implemented and what were the size of the features that you implemented in the first sprint, and you can actually extrapolate that and decide how many sprints it's going to take you to run through the entire backlog. The second thing about costs is there are two parts to this. One is, of course, changing requirements, but then because you have a prioritized backlog, the most important features get done first. So as a customer, there are two aspects. One is you get software with your most important features right up front. The second thing is the least important features are at the end. So should there be a schedule overrun, you can always decide to cut down the least important features to maintain the cost, or with changing requirements you might decide, let's add a more important feature up front and cut down a least important feature at the tail end of the project. So that kind of optimization is possible. Plus, a customer is free to cut the project in the middle when they think that they're getting enough ROI. They can just say, okay, the rest of the projects, the features are not so important, let's do them later. We've got all the important things up front, and thereby control their costs. And we got another question, what software do you use for the backlog? Well, there are many options. My company has an online project management tool. So if you go to toolsforagile.com, we have a tool where you can also maintain your backlog. That's what we use naturally. Apart from that, there are a whole number of other options like Excel or spreadsheets where you can just put your backlog there, or you can just put it on a wiki page. These are all various different kind of options. Some people even just have a chart with the cards and they stick them on the chart. So you can either use a tool like what we provide, or you can go in for something more low-end like an Excel sheet. Okay, so that pretty much wraps up the questions. Thanks for all your questions. We'll now head over to the second part of the presentation. Hari will be taking it on engineering practices. Over to you, Hari.
Yeah, thanks, Siddharth, and thanks everyone for joining the session. Here we'll be discussing two things. One is what are the needs for good engineering practices, and we recommend some of the engineering practices. We discuss both things here. Okay, so I'd like to reiterate some of the points that Siddharth has mentioned earlier. So if you see that left-hand side, you can see a box and with a partition with the lines in it. So you can think that as a sprint. So if you see that this is a list of the features we are going to do in a product, and we are going to prioritize, and based on the priority, we move the most important things and we move the least important things down the stack. So this is the way how Agile works. And at any point of the time, the product needs to be shippable. And any point of the time, the customer may start working on the product, as Siddharth mentioned, if they have enough ROI. So if you see that some of the attributes of Agile, you can see that Agile builds working software on top of a working software, on top of a working software, so on and so forth. What does it mean? If you see the two triangles there, the rightmost would say the app for Agile. So we are building a concrete on that, and then we add some more features to it by adding side features. Then we add some more features to it. So at any point of the time, we are getting an working software. If you see in a traditional development, there is every possibility the product may not be get completed due to several constraints. So the second point is that each increment is defect-free, that is potentially shippable. So what does it mean? So if you are done with one scrum, then it means that we can ship the product. So that need to be defect-free. And I said that it need to be a working software on top of the working software. The design need to be very good. And the refactoring keeps design clean. So refactoring is one of the key factors when you talk about Agile. And we have automated test acts as a safety net. And the last we have the continuous integration finds defects earlier. So being said that we are having working software, potentially shippable software, we are having refactoring. So these are the things which really wants us to focus towards having a good engineering practices. So let's talk about what are the engineering practices we emphasize on. So even though the list is going to be pretty big, so we will be emphasizing on eight good practices which need to be there in Agile development. So some sounds like generic, but it is apt for Agile as well. The first practices we like to emphasize here is on dip deep into requirements. So in an Agile perspective, what we want to more focus is, so if we see what are the properties of the requirements, we can see that the requirement need to be perspectives, it need to be unambiguous, it need to be complete, necessary and feasible. These are the main properties. But what we like to emphasize here is the quality of service, which is otherwise known as the non-functional requirements. So this is going to play a critical role on success of the product. So for example, if you take that one of the quality of services, all middle tier objects should load from the database within 3 seconds. So it is a quality of service. It is a non-functional requirement. So what we need to take care here is we need to adhere to all of the quality of services. Otherwise, we will end up in having a bad design in place. So that will not allow us to go into have a working software on top of working software. See, the other quality of service would be the application should scale up to 50 concurrent users with the current server configurations. So this is the point we need to make sure. So these are the NFRs which is going to play a crucial role. So what we really mean by deep into requirements is concentrate more on the quality of service or non-functional requirements. Okay. So the second point here is write structured code. So what do you mean by that is write your code into smaller pieces and split it into multiple functions and methods. And if you have a common functionality, extract that common functionality into a library and never duplicate the code. So this is pretty much normal, which holds good for even the traditional. But in the Agile perspective, this has more value to it. So we also need to keep in mind that we are going to ship a working software at the end of every sprint. So this writing a structured code is going to play a crucial role because in the next Scrum we are going to build something on top of the previous one. So how to make sure that our code is being structured well, or what are the matrices available for doing that? So here we have five matrices which can help us in really doing it. So one is a class coupling, the second one is a depth of inheritance, the third one is a cyclomatic complexity, and the fourth one is lines of code, and the fifth one is going to be maintainability index. Out of these five, the third and fifth are more important, cyclomatic complexity. So what does it mean? So we will touch base this matrices during the other good engineering practices. So what it gives to the customer is, so based on the cyclomatic complexity, we can derive what are the amount of test cases we need to write to make the test case pass on it. So assume that we have a cyclomatic complexity as 10, it means that we potentially need to have 10 unit test cases for that product or a functionality. And the maintainability index. So this will give a high clue of the code whether it's maintainable or not. So if the index is going to be between 20 and 100, it means that it is highly maintainable. And if it is going to be between 10 and 90, it is going to be moderate. And anything below that, it is going to be a very low maintainability. So we need to concentrate on how we are going to structure a code that is very critical for success of Agile project. So let's move on. Okay, so here the third engineering practices we like to emphasize on is use code analysis tools. So what the code analysis tools can give us is, it can help us to adhere to standards and the guidelines from the industry. So industries keep on adding the guidelines, the recommendations based on the experience and the customer's feedback. So these tools can really help us to validate our code against these standards. And there is an additional advantage of going with this is, this can be automated. So once you identify the tool, we can automate the tool so that whenever there is a shippable code, we can run all the practices and guidelines on top of it and see whether it's still adhered to the standards. Okay. So if you see in the .NET perspective, we are having one tool known as FXCOP, which is an abbreviation of Framework Police. So this tool works on and manage assemblies. These have an extensive set of predefined tools, and this tool will also support high customization options. So we can go ahead and customize the rules based on your need. Okay, the screenshot is going to be something like this. So if you see that on top of on high level, we are having design rules, globalization rules, interoperability rules, naming rules, so on and so forth, and each section is having multiple items to it. So if a developer might not aware that his code is going to break any globalization rules, because if it is going to, it need to be adhered to the globalization. So if the developer might not know whether some of his code is going to break when based on the deployment culture. So these tools like FSCOP can really help us to identify the bugs in this or in the code quality upfront, so that we can go ahead and refactor the code. Okay. So the fourth engineering practices which we like to emphasize on is automated unit test cases. So this is pretty much needed for Agile. So what is the advantage of going for unit test case? We'll see it in the next slide. So what automated test can provide us is, it can say the coding with confidence, or in Microsoft terms, it will be a first line of defense. Okay, by definition, what it means is the unit test is going to be written by a developer to test a very small specific area of functionality. So this is by definition. So it is unit test is going to be written by the developer, and it is going to be testing only small and very specific area of the functionality. So being said this, I would like to touch base on test-driven development, which is the best fit when you are following an Agile-based methodologies, and TDD fits very well into your XP, Scrum, or whatever the project management you are going to follow. Okay, what TDD means is, TDD is a technique whereby test cases are written before code implementation. This is very critical. So before implementing the code, we have the test case in place, and for the test cases, we write the code and make it pass for it. In the other sense, test tries or dictate the code that is developed. So the test case is going to be serving as a reference for the developer, for which he is going to write code for the implementation. Okay. So if you see the hierarchy of requirements, we have the needs from the customer, then that has been drilled down to features. From that we have use cases, supplements, and in the bottom list we have the unit test case and the test cases. So this is the hierarchy. So what TDD says is that these are the stages of a test-driven development. So there's 8 stages in place. So first one is write a single test. Compile it, because it will not compile because we don't have anything implemented there, and it is going to fail for us. So the third stage, what is it? Implement just enough code to get the test to compile. Here if you see that just enough code, we don't want to write more code. We want to write just enough code so that it gets compiled at first point. Then run the test again. It is going to fail because it is just compiled, but it has no implementation on it. And the fifth stage is implement just enough code to make sure the test is getting passed. Once it is passed, run the test and make sure that it is passing. And the seventh step says is refactor for clarity. And then once you are done with the seven steps, you repeat the process. So this is for the stages of the TDD. So in other way, it is going to be read, green, and refactor. So write the test case, see it fail, make the app implementation, see it pass, and then refactor a code to make for a more clarity and structuring. So we like to emphasize on refactor. So what do you really mean by refactor? Let's discuss a little bit about that. So by definition, what refactoring says that this is a process of changing a software system in such a way that the external behavior is not altered, but the internal behavior will be highly improved. This is what we mean by the code refactoring. Okay, why we need a code refactoring? So definitely it is going to improve your coding structure and design. It is going to improve our maintainability of your code, and it is going to be easy to understand and easy to modify and easy to add features to it. So this is very much important because we are going to add features on top of something working software and so on and so forth. So unless you don't have a refactored code, it is very difficult to maintain, and adding features to it is going to be a big problem. Okay, there is a famous quote from Ken Payne. What he says is, programs have two kinds of values, what they can do for today and what they can do for you tomorrow. So normally in a typical development, we only concentrate on what we are going to do today. We'll least bother about the future transition. So these kind of refactoring will help us to do the transition very smoother. Okay, when to refactor, this is another vital point we need to emphasize. So whenever you add a new feature to the code and you feel that the code is a bit brittle or it is very hard to understand, then there is a possibility of refactoring. So when you fix bugs, so that is a good chance. So you introduce some bugs to the system, so there is every chance for refactoring. Go and review the code and get it refactored. And in the general review process, once you're done with the development, you're going to do a self-review or a peer review. There is every chance the code can be refactored. So in these three circumstances, we'll ideally go for refactoring. Okay, let's move on. Okay, we talked about test-driven development in context with unit testing. So let's get back to unit testing. So we have two diagrams here, and one is in the axis we have productivity and time. One is pay as you go, other was a single test space. The testing is unavoidable. It needs to happen in some way or the other in the development cycle. So what is the productivity advantage we are getting as and when we write unit test cases? And what is the productivity we are getting when you are going to do a single test space? That the diagram explains in detail. So the if you see that left-hand side, the productivity is going to be very consistent because you write the code, you know that you are going to run a unit test case on top of it, you know that it fails, so you fix the bug and then you refactor it. So we know that the code is out of quality. It is always in quality. If you say a single test space, even though it starts with a high productivity, during the course of time, it is going to decline for a longer time. So being said that, what are the good characteristics of a unit test case? So how do you define a unit test case? What are the characteristics which defines a good unit test case? So these 5 points will address that issue. The unit test case should run quickly. It needs to run pretty fast because we cannot expect a developer to sit idle for a long time before his computer to make sure that the test runs for us. So it needs to run pretty fast. And the intention of the test case is we need to test only one thing. This is very important because if we have dependencies, we are going to test more than one functionality, then we definitely have no clue which functionality has really broken the code and we end up in a mess. So we need to write a unit test case which is going to test only one functionality at a time. The third point is isolates or simulate environmental dependencies like your file system, like your message queuing, or it may be a database. So you need to simulate the environmental dependencies because any failure on an environment is going to affect the unit test case. So in that cases, we need to do some simulation and make sure that the unit test case runs on top of it. The fourth point is it needs to run in isolation. What it means that is the test can be automated or it can be run against any machine. So if the developer says it runs very fine on my machine, it is not acceptable at any circumstances because we are not intended to run the test cases in a developer machine. We need to do that on a server side. So it needs to run on isolation level. And the fifth point is use stubs and mock objects. So when we say that we want to simulate the dependencies, we need to have some mechanism for it. These stubs and mock objects will really help us to do the mocking and you can simulate the environmental dependencies. Okay, let's move on to the next one. So here, what we are saying is test early and often. So prevention is best and cheapest, but the sooner the defect is detected, the easier and cheaper it is to fix. So what we really mean by this test early and often is, we are talking here about the continuous integration. So what it means that is, so by definition, continuous integration is a software development practice where members of the team integrate their work frequently, usually on a daily basis. So this is very much needed for the product integration. So what we mean by product integration is, we have, Siddharth talked about the distributed agile. So we will have the product being synchronized on a single server, so that we need to do an integration. And CI is the one which is going to help us in identifying whether the integration is really successful or someone else's code really broken the build. Okay, what are the need for continuous integration? So if you see here is, the ultimate aim is to protect our code base. So it is a 3-step process. Step 1, what we we'll do, we'll have the source control, which is going to have the historical repository of changes. The second step, we are having unit test case that is going to give you an instant feedback. And the third step is going to be CI. So what we are meaning by third step, what we are going to do here is, CI is going to ensure as soon as possible there is any break in the code. So that way CI really helps, and it keeps all the stakeholders, developers, and everyone in the loop that something has gone wrong into the build or something has gone good into the build. So what are the tools available for doing the continuous integration? We have something known as cruise control.